Hi students, today we can discuss the sixth module of the subject ME 312 Metrology and Instrumentation. I am Radhakrishnan, Assistant Professor, Tokach Institute of Science and Technology, Cochin. In this module, it consists of measurement of strain, then force, torque, temperature measurement and vibration. First, we can discuss on strain. Strain, as we know, it is a ratio of change in length to the original length. Stress and strain are related, and stress can be calculated by calculating the stress from the force which is got by a Newton's laws. The force divided by area, cross-sectional area, will give the stress measurement. Hence, it is a calculated quantity or a derived quantity. But strain can be measured directly with a deformation. Hence, it is a direct measuring characteristic, that is strain. Strain gauge is an example of passive transducer. Transducer means it converts one form of into another form or electrical signal. Here also a strain gauge which takes the input as strain or deformation, and output is in terms of electric signal or resistance. Strain gauge is an example of passive transducer that converts a mechanical measurement into a change of resistance. A strain gauge is a thin wafer-like device that can be attached to a variety of materials to measure applied strain. Here you can see that the strain gauge is connected to the fourth arm of a Wheaton's bridge. Only one strain gauge is connected, that is why it is called a quarter bridge. Suppose in the same Wheaton's bridge, if you are connecting two strain gauges, means it is half bridge. At the same time, if four strain gauges are connected to the Wheaton's bridge, it is called full bridge. Now in this figure it is a quarter type, that is quarter bridge strain gauge. The strain gauge is connected to a Wheaton's bridge circuit. Change in resistance is proportional to the applied strain and is measured with the Wheaton's bridge. This is a principle, this is a working of the strain gauge. The sensitivity of a strain gauge is described in terms of characteristics called gauge factor. Gauge factor is K. That is unit change in resistance per unit change in length, or K is equal to delta R by R divided by delta L by L. Delta R is the changing resistance of the Wheaton's bridge circuit, and R is the resistance of underformed condition, that is before deformation we are measuring the resistance, means that is called R, and under deformation there will be a change, that is called the change in resistance is delta R. Suppose the resistance changes from 100 to 120 milliohms or ohms, that 20 ohms is a change. Delta L is a change in length by the application of force, that is that is strained length, that change in length, that L is the original length. Suppose a component is having 100 mm and we are applying a force, and the final reading after applying the force, it will be 102 mm, means that 2 mm is a change in length. So the strain delta L by L, delta R by R can calculate, and from that we can calculate the sensitivity, that is called K. You can see the structure of a strain gauge. The majority of strain gauges are foil types available in a wide choice of shapes and sizes to suit a variety of applications. That means the selection of the strain gauges depends upon the application. They consist of a pattern of resistive foil which is mounted on a backing material. They operate on the principle that as the foil is subjected to stress, that is, we are applying some kind of force or something, then resistance of the foil changes. That is the principle. There are many types of strain gauges based on principle of working, that is mechanical, electrical, piezoelectric, based on mounting, bonded and unbonded, based on construction, foil type, semiconductor and photoelectric strain gauge. Mechanical strain gauge, it consists of two separate plastic layers, bottom and top layer. Bottom layer is connected to a scale, it is glued with a scale, and top layer which is have a pointer, a red color pointer will be there. Suppose when you are measuring the strain, for example, if you are measuring the extension of a MS rod in universal testing machine in material testing laboratory, we can keep this mechanical type of strain gauge. So we are marking the center of the component between the jaws, and one layer of the mechanical strain gauge is glued to the part which is below the center line, and another part of the mechanical strain, the top layer, that can be fixed above the center line of the workpiece. So the top layer has a pointer and bottom layer has a rolled scale, that is marked scale, and when we are applying the force hydraulically, the component extends and the pointer moves on the scale. That is, hence we can measure the deformation or the strain from the scale. Electrical strain gauge, when an electrical wire is connected or stretched, we know that within the limits of elasticity. Within the limits of elasticity means when we release the force, it will regain its original size and shape. That is within the elastic limit. So electric wire is stretched such that it does not break or permanently deform. Then the wire becomes narrower and longer and changes that increase the resistance of end to end. That is electrical strain gauge principle. Photoelectric means it will generate an electric voltage when strain is applied over it. Strain can be calculated from the voltage. Piezoelectric strain gauges are very sensitive and also reliable devices. Bonded strain gauges, that consists of a metallic wire, etched foil, vacuum deposit film or semiconductor bar, and is pasted or cemented to the surface for which the strain is measured. Unbonded type strain gauge is also available. It has two leads, 2 points of in insulating medium such as air. One end of the wire is fixed and the other end is attached to the movable element, that is the measuring side, or the component which is subjected to deformation. Foil strain gauge is a very common strain gauge actually. It has a metal foil photo etched in a grid pattern on an electric insulator of thin resin and gauge leads attached. It's a common type strain gauge. Semiconductor type is also available nowadays for measurement of small strain. Semiconductor strain gauges, so called piezo resistors, are often preferred over foil gauges. Semiconductor strain gauges are depend on the piezo sensitivity effects of silicon and germanium and change in the resistance with stress as opposed to strain. That is why we are using semiconductor type of strain gauge. Photoelectric means photoelectric strain is a light beam with the two gratings and photocell detector to generate an electric current that is proportional to strain. So strain is more means the detector, the photocell detector, it will generate an electric current that will be more. The gauge length of these devices can be short as 1/16th of an inch, but they are costly and delicate, and for the highly precise and accurate measurements we are using photoelectric type of strain gauge. Mechanical strain gauge already explained. It is used under static or gradually increasing or varying loading conditions. Nowadays it is called extensometer. Now it has two knife edges. They are clamped firmly in contact with the test component at a specified distance. And when the test equipment is strained, that is why we are applying the force. The two knife edge undergoes small relative displacement. This displacement is amplified through a mechanical linkage, and magnified displacement of strain is displaced on a calibrated scale. From that we can calculate the strain. Mechanical strain gauge has different types, that is Berry strain gauge. This is most commonly used. That is the center you can see the specimen and clamping points, and then the two knife edge points are there, that is between which that is called gauge length. The lever arm and dial gauge measure strain down to 10 microstrain over a 50 mm gauge length we can measure up to. Okay, when this specimen is subjected to tensile load or compressive load, then the knife edges also moves along with that. Then this pivoting will actuate the dial indicator, and dial indicator shows the displacement, that is the deformation. Johansson extensometer is the principle just as Johansson microcator, that is a comparative measurement instrument we are used in comparative measurements. That is a twisted wire actually, in between a twisted wire is there. So when the extension or deformation happens, this wire, this central part of the torsion tape, that will be winding or unwinding will happen. Accordingly, the pointer will move on the scale. Now we can read the explanation. Torsion tape stretched between knife edges. Half inch is twisted in one direction while the later is in another direction. Measure a strain down to a 5 microstrain over a gauge length of 50 millimeter. Resistance strain gauge, it is valuable tool discovered by William Thomson. Basic principle of resistance strain gauge is that electrical resistance of copper iron bar changes when a wire is either stretched or compressed. That is, resistivity is directly proportional to length. Change in resistance is amplified and converted into strain. This is bonded type strain gauges. It has a lead. Copper wire carries a lead. The carrier may be impregnated paper A bond has been made between the surface to be strained and the gauge by means of adhesive material. What are the advantages and disadvantages of strain gauges? There is no moving parts. Then strain gauges are very small and inexpensive, highly economic, and fast measurement. And disadvantages are it is non-linear, that is why it is a cumbersome calculations for finding out the strain. It needs to be calibrated because we are getting resistance change. It should be converted into the deformation strain. That way there is a calibrated scale should be there. Accuracy decreases by repeated use because strain, suppose the strain gauge itself will be subjected to some kind of strain and it will be permanently deformed, and there is a chance of accuracy problem when we are using it repeatedly. Applications: residual stress measurement, vibration measurement, torque measurement, then bending and deflection measurement, compression and tension measurement, strain measurement. We are using this kind of strain gauges. Thank you for listening. Thank you.